Hey everyone. Hope we're having a good day. It's super sunny here today, so it's really awesome going into the weekend. We're going to take notes on functions today. So what is a function? What does it look like in a table? What does it look like in a graph? What does it look like in an equation? What does function notation look like? How can we use it? Things like that. So as always, make sure that you start off with the date right at the top of your notes. And the title of today's notes is functions. Okay, and this is going to be a very general overview of what is a function. Okay, there's so many things that we could be talking about. And we will talk about a lot of them, but just for today, it's just going to be a general overview. So we're going to start with defining what is a function. Okay, what is a function? So a function is a relation. So this just means like a relationship between numbers, okay? So a relation in which each x value, so each x value or each input, right? Because x values and inputs are the same. So each input only has one y value or output. Okay, so once we're done and we've got this written in, I'm going to try to explain this a little bit easier. So what this means is that for any input, so let's talk about an equation, okay? If I plug in 2, and let's say I get out 7, okay? So if I plug in 2, I get out 7. So 2 has an output of 7, so that's good. If I plug in -3, maybe I get an output of 5. Right? So for every number that you put in, you can only get one number out. So an example of something that would not be a function would be if I plug 2 into an equation and I can get out 7 or -7. Right? If I have 2 options on what I can get out, then that is not a function. If I plug in 3, or what did I say, -3, and I can get out either 5 or -5, that's no good. If I plug in 22 and I can get out either 11 or -14, that's no good. Okay, so for every input, you could only get one output. And that's what makes a function a function. Okay, so we're going to look at some facts and characteristics and examples and non-examples of a function for both, or for all three, of a graph, a table, and a equation. Okay, so I'm going to go ahead and erase this because I'm going to need some more room here. And I'm going to scroll down since we don't need that heading anymore. And let's do like one for each color. So let's talk first about a graph. A graph. How do I know if a graph is a function? Okay, so the characteristics basically is that there's no points exactly vertical. Exactly vertical of each other. Okay, or in other words, we can say it passes the vertical line test, which we will talk about later on in this video. So just write it for now, and then we will talk about it in a couple minutes, okay? So there can be no points exactly vertical of each other. So wow, words, right? So an example of a function would be something like, let's say, a parabola. right? At no point, if I draw or if I look, there's no points that are ever exactly vertical. Even though it may look like they are, right? As we get into these steeper sections, they're never exactly vertical of each other. So that would be an example of a graph that is a function. Another example would be just a straight line, right? That's another example of a graph that is a function. At no point are 2 points exactly vertical of each other, okay? A non-example, and I didn't leave myself very much room here, but that's okay, we can make it work. A non-example would be like a sideways parabola, right? So here's a sideways parabola. And I do have points that are vertical of each other. So if I get another color here, right? If I were to, like this point right here is exactly vertical from this point. And I can't have that, right? If this is my input, that gives me two different outputs, one up here in the positive and one down here in the negative. And I can't have that. So this would be a non-example. And I'll never get that same color green back, but that's okay. Non-example, right here. So this is not a function. Not a function. So that's what it looks like when we're talking about graphs, okay? Now let's talk about tables. So let's go like a pinky, not right, a pink color. Ideally, I'm going to do all three right next to each other, but I have to write a little bit bigger on the screen. So just know that I ideally would have all of them right next to each other. So now let's look at a table. How do I know if something is a function from a table? So in writing, basically what we're looking for is no repeated x values. No repeated x values with different y values. Different y values. Right? Because I can't have two x's, I can't have one x go to two different y's. So if I have like 2 and 3 and then 2 and -5, that's no good. I can't have that. Okay? So an example of a function in a table, so here's an xy table. An example would be like 2, 1, -4, 3, 2, 1, 5, -6. So in here, I do have two repeated x values, but notice they have the same y value. So because they have the same y value, this is okay. This is a function. You also, another example, and I should probably write like examples. Another example would be is if you have like, I'm just gonna make up numbers here. In this case, I don't have any repeated x values, and that's okay. And even if I had repeated y values, let's look at this. Even if I had these as all 5s, that's okay. You can have repeating y values, you just cannot have repeating x values, okay? So those two are both examples of functions. A non-example would be a table like so. And my x values, let's do 2, -4, 2, 5 again. So same numbers as above. And then 1, 3, -7, 6. So here, because I have a 2, 1 and a 2, -7, that is not okay. Not okay. You cannot have an x value repeated twice with two different y values. So this is not a function. It's not a function. So hopefully that's making sense. You cannot have the same x value with two repeated y values. Okay, the last one that we're going to look at is in a table. Or, sorry, wow, no, not in a table. In an equation. How can you tell if an equation is a function? So in a table, in an equation, wow, my mind is really not focused today. So in the equation, how do I tell if an equation is a function? And it's pretty much what we've been saying this whole time, right? So only one output is allowed for each input. So only one output per input, meaning if I plug in a number into the equation, I can only get one number out. I cannot get two different numbers out. Okay, so an example of what of an equation that is a function would be like, I don't want to use that notation. Be like y is equal to x squared plus 2x plus 3. Okay, no matter what number I plug in for x here, I'm going to only get one number out. So that's really important, right? So if I plug in 0, then 0 squared is 0, right? Plus 2 times 0 is 0, and then plus 3. So I would get 3. So if I plug in 0, I get out 3. Only option. If I plug in 1, I get 1 plus 2 is 3, plus 3 is 6. So if I plug in 1, I get out 6. Only option, okay? So that's an example of something that would be a function. Another example could be like 2x plus 5, right? That no matter what I plug in there, that only gives me one number out. So if I plug in 0, I get out 5. If I plug in 1, I get out 7. If I plug in -2, I get out 1. Okay, so no matter what, I only plug in one number, I get out one number. Okay, a non-example here would be something like y is equal to plus or minus the square root of x minus 4. So the reason that this would be not a function, let's go through it. If I plug in, let's say I plug in 5. 5 minus 4 is 1, right? And then the square root of 1 is 1. But then I have this plus or minus here. So that means if I plug in 5, I can get out either a positive 1 because of the plus or a negative 1 because of the minus. And so what this does is it gives me two answers. If I plug in 5, I can either get out 1 or -1. On the same note, if I plug in 8, 8 minus 4 is 4. The square root of 4 is 2. But I have this plus or minus. So if I plug in 8, I can get out 2 or I can get out -2. So this would be an example of not a function because there's two possible outputs. Two possible outputs here. So that would not be a function. Okay, so that's what a function looks like within a graph, a table, and an equation. Now we're going to get more into what can we do with our functions. But before we do that, we are going to talk about function notation. So just real briefly, we're going to talk about function notation. All right, function notation. So what we're going to say here is if an equation is a function, if an equation is a function, so if it passes that criteria, right? So if there's only one output per input, then we can use function notation. Then we can use function notation. So what is function notation? Okay, well, good thing, because I'm about to show you, right? So this is when, and I know you guys have seen it before, we have f of x. Okay, so this is our function notation. So we can use this in place of y. Okay, so instead of y equals 2x plus 3, we can use f of x equals 2x plus 3. So how do we say it, first of all? And you've heard me say it now a couple times. So when we say it, we say f of x. We don't say fx. It's not a TV channel that plays Marvel movies and all sorts of other things, right? Okay, it's f of x. And what this f is, this guy right here, it's just the name of the function. Name of the function. And you can name the function anything you want. You can name it g, you can name it h, you can name it m, you can write whatever. We typically use f just because it stands for function. But if we're talking about multiple functions, the common ones that we use are f, g, and h. So we could have f of x, g of x, or h of x, or the common ones. And then this guy right here is just the variable within the function. Okay, so if this is f of y, that's okay. That just means there has to be a y in your function. So I want to show you a couple like little examples here, kind of off to the side. So for example, if I have g of y equals 2x plus 5, this does not make sense because this right here is telling me that the variable in the equation has to be a y. But over here, the variable is an x. So that doesn't make sense. So this variable right here would have to be a y in order for that to make sense. And all this just says is that the name of it is g and the variable is y. And you can use this in place of y equals, okay? You also could have like h of x and has like 2x squared plus 3y or something. Again, this is okay still because there still is an x. It just means that whatever number I'm plugging in, I cannot plug it into y. I can only plug it into x because x is my variable. So we're going to do some examples here, and we're going to look at some evaluation of functions, and then we're going to determine if things are functions or not. So we're going to practice that, okay? Well, let's start with a couple examples. We have 3 examples here, okay? So our first one is to evaluate. So remember, whenever it says evaluate, we're just simplifying. So evaluate f of x equals x squared. And I know that this is a function because it's already using function notation. Okay, so I don't have to question whether or not this is a function. But I want to evaluate this when x is 4. So if x is 4, that means that this right here is 4, and this right here is 4. So all I'm going to do is replace x with 4. So I have f of 4. So what this says is, hey, if I plug 4 into the f function, well, here's the f function, right? And then I have another x right here, so but x is 4. And so now I can just simplify. So f of 4 equals 16. And this is a mathematical sentence. right here. This says if I plug 4 into the f function, I get out 16. So I'll say that again. If I plug 4 into the f function, I get out 16. So it's really important that you write this whole thing, right? You're telling me which function you're using. In this case, I'm using function f, which is right here. You're telling me what the input is. What are you putting in? And in this problem, I'm plugging in 4. And then it tells me what I get out. So if I plug in 4, I get out 16. Okay, let's look at another one. So here we have oops, there we go, g of z equals z plus the absolute value of z. So again, this is okay. This tells me that the name of my function is g and the variable in my function is z. Okay? And I want to find g of -4. So what this means is, hey, I want to plug -4 into the g function. Well, here's the g function, right? The whole thing. And I want to plug in -4. So I have g of -4. And I'm just plugging in -4. So -4 plus the absolute value of -4. Okay, and then I'm just going to simplify. So I have -4, and then the absolute value of -4 is 4, so this is -4 plus 4, which gets me 0. So g of -4 is 0. So what that means is, again, if I plug -4 into the g function, right, the function named g, I will get out 0. So hopefully that's all good. Let's look at one more little bit different of a problem here. But one more example. So this example says find the value of y when h of y equals 10 for the function h of y equals 2y minus 4. Okay, we have to be really, really, really careful here because I'm not told that y is 10. Okay, because that's always our first instinct, right? Oh, just plug it in for y and it'll be fine. But I'm not told that y is 10 here. I'm told that h of y is 10. And so then the question is, what is h of y, right? What does that do for me? So h of y is 10. Well, here's h of y right here. So that's telling me that this whole thing is 10. So I just get 10 equals 2y minus 4. And now it wants me to find the value of y. So it wants me to say, what do I have to plug in to my equation in order to get out 10? So that's what we are finding. What do I have to plug in order to get out 10? So I'm going to add my 4 to the other side. So I have 14 equals 2y. Divide both sides by 2, and I get y equals 7. Oh, actually don't. So y equals 7. So that tells me that in order to get out 10, I would have to plug in 7. Okay, so h of 7, if I plug in 7 into the h function, would get me 10. So y is 7. If I plug in 7 into the h function, which is right here, I will get out 10. So I want this to be very, very, very clear. H of 10 is not the same thing. Look how big I'm writing this, as h of y equals 10. This one on the left tells me that my input is 10. I am plugging in 10 into the equation, into y. I'm plugging in 10. This one tells me that my output is 10. What do I have to plug in order to get out 10? So these two things are not the same, and I know that they look the same, and it's very tricky. Okay, this is a really tricky kind of like step, I guess, of functions, right, is knowing the difference. But we need to make sure that we're paying attention when we do these. Okay, let's go on. And let's look at, how do you know if your equation is a function? We're going to look, is my equation a function? Question mark. There we go. Is my equation a function? Right, and so we already know if you can get out two separate values, it's not a function. So let's write that. If it has more than one output for each input, it is, wow, I switched those two words up pretty easily, huh? Sorry. It is not a function. So let's look at a couple examples here. I wonder if I can fit them all here. So y equals 2x squared plus 7. Notice that I have y equals because I don't know if this is a function. I can't write f of x until I know that it's a function. So if you don't know, we could just plug in a number. Let's pick a number. Let's do like x, x equals 3. Let's just say. So if I plug that in, I have 2 times 3 squared plus 7. And we're just going to solve. 3 squared is 9. 9 times 2 is 18. Plus 7. And I get 25. So how many outputs do I get when I plug in 3? Right? I only get 1. And it's 25. Okay, so only one answer here. Only one answer. So now that I know that it is a function, now I can use function notation. I can say that f of x equals 2x squared plus 7 is a function. I could not say that before, so I had to use y equals. Okay, I had to use y equals because I did not know if it was a function or not. Okay, let's do another one. Let's do like x equals y squared minus 5, let's say. And let's do like x equals 4. Okay, so I plug in 4. We have 4 equals y squared plus 5. Oh, sorry. Minus 5. Add 5 to the other side, so I get 9 equals y squared. Right? So take the square root, take the square root. and I get y is equal to, and when you solve by taking the square root, you cannot forget your plus or minus. So I get y is equal to plus or minus 3. So either positive 3 or negative 3. So if x is 4, I actually get two outputs, either positive 3 or negative 3. So because there's two possible, my pin's starting to get kind of jumpy on me, outputs, because there's two possible outputs, so the equation x equals y squared minus 5 is not a function. It's still an equation. It's still a valid equation. It's just not a function. So we just have to call it an equation instead of a function. So hopefully that makes sense. We can just plug it in. So if you're trying to figure out if your equation is a function or not, just plug in a number and see what happens. And then the last thing we're going to look at is my graph a function? Is my graph a function? Okay, so now we're going to talk about the vertical line test. Woohoo! The vertical line test. VLT, vertical line test. So the vertical line test, and I'm going to write it out, and then when we do our examples, I think you'll be like, oh, that's super easy. Okay. If every possible vertical line, so how many possible vertical lines are there? Infinitely many, right? Like every single little vertical line. Infinitely many. Okay, but so if every single one of those intersects a graph only once, at every input, then the graph is a function. And that's a lot of words, so let's just talk about it as you get caught up on the writing, okay? So if any line, so I have some sort of graph, right? And then any line I draw, if it only touches that graph once, okay, along every single point, then it is a function. It passes the vertical line test. So what we're going to do, and this is going to turn out really poorly because my drawing skills are subpar, right? So let's draw, I'm going to do it over here. Wow, see, look at that. That was awful. Okay, I can do better. Okay. Okay, there's a graph. And let's just say that I have a graph that's, holy cow. Did you guys see how much my pin just jumped? It was crazy. Okay, let's say that I have a graph that's doing this. I'm just making stuff up. Just so you guys know. Okay, so the question is at any vertical line. So I'm just going to start drawing like some vertical lines here, right? So here's a vertical line. That only touches the graph once, right there. Here's another random vertical line. That only touches the graph once, right there. Here's another random vertical line. It only touches the graph once. This vertical line only touches the graph once, right? So on these vertical lines, will any vertical line along this whole graph only touch the graph once? And the answer is yes, right? So let's get rid of this. So any vertical line, let's make a little note here, any vertical line touches only once. So that means that this graph is a function. Okay, let's look at an example of what not a function would look like. Okay, pick a weird pink color. Let's say that I have a graph that's doing this. Okay, if I were to draw some vertical lines here, like here, only touches once, that's fine. Here, once, it's fine. However, here, I touched twice. That's not okay. Even like here, I touched 3 times. That's even more not okay. All right, so here I have vertical lines. I can draw vertical lines that touch more than once. So touch the graph more than once. So because of that, this does not pass that vertical line test, okay? So this is not a function. Not a function. So that's it for our notes today. Just a quick overview of what is a function, what is not a function, how do you find it, how do you recognize it, things like that. We will do some practice next time I see you, and then we'll just move on to the next section. So I'll see you guys later.